Hello and welcome back to our session where we are getting an insight into marshalling and headset operations.
Well, Professor, looks like that aircraft is getting ready for pushback. So shall we move on to the module on headset operations? Professor, why do aircraft need pushback?
Aircraft need pushback in two cases. The first being when the aircraft is parked with nose facing the opposite direction from the taxiway. Since aircraft don't have a reverse gear, they need to be towed or pushed back to correct position. In the second case, when an aircraft is unable to start its engines due to proximity with the terminal building, which would result in jet blast damage.
Oh, looks like there is some problem. The captain has just communicated to the headset staff that a passenger is being offloaded.
As you can see, Professor, the headset staff now has to do a visual check of all doors that have been opened once again before resuming pushback operations.
Can you tell us the process involved in pushback in a little detail, Professor?
Yes, of course. Let us first see who the people involved in the pushback operation are. The cockpit staff, the headset staff, also called walkout assistants,
the tow truck driver.
The equipment that is used in a pushback operation include the tow truck or pushback vehicle, the tow bar, and the bypass pin.
Professor, we just saw the headset staff and the tow truck or pushback vehicle, as it is called, in position to start the pushback. And he has done a walk-around check. What is the next step of the operation?
Well, now that the tow truck is in place, the headset staff first receives confirmation from the captain that the tow bar may be connected. The tow truck staff has to ensure that the truck engines are running and he never switches it off during the operation. The headset staff then attaches the tow bar, first to the aircraft and then to the tow truck, after which he then attaches the bypass pin.
The bypass pin is a very important piece of equipment, is it not, Professor?
Yes, as once the bypass pin is inserted, steering control of the aircraft passes from the flight deck to the tow truck.
What do we mean by control passing to the tow truck, Professor?
Quite simply, it means that the bypass pin, once inserted in the nose gear of the aircraft, disconnects the aircraft from its normal steering mechanism. It reduces the mobility of the aircraft, and the aircraft movement is now controlled by the tow truck.
Is the pushback operation ready to start now, Professor?
Not so fast, Professor. The headset staff receives the all-clear signal from the wing walkers that there is no obstruction. The headset staff communicates to the flight deck that the brakes must be released and checks the brake lamp on the front strut to make sure it's off. Now, tow truck starts pushback.
When the tow truck starts pushback, the headset man has to walk alongside the tow truck at a walking pace. In case the tow truck is moving too fast, the headset man must not speed up his pace but signal to the tow truck driver to slow down. In case the communication cable comes loose for any reason, the headset man has to immediately stop the pushback operation. He signals the tow truck driver to stop. He signals to the captain for an emergency stop. He then signals to the pilot that the brakes should be set. Walks up to the aircraft and reconnects the cable. Walks back to his position and gives the thumbs up, and only then start again. When the pushback vehicle starts turning in order to turn the aircraft, the staff performing the pushback gets into the risk of entering the dragging area of engines. To reduce risk, the headset staff has to reduce his pace further and walk parallel to the tow truck. At this time, it is important to note that eye contact with the tow truck driver is not possible. The headset man needs to keep a close watch on the tow truck and remain a few steps behind it. The headset staff should always walk on the inside of the turn, whichever side the aircraft is turning during pushback. This is to avoid injury in case the tow bar swings, since the tow bar always swings to the outer side. When does the captain start engines, Professor?
Well, when the aircraft starts engines depends on several factors. The first is proximity to terminal. In case the terminal is in the direction of jet blast, then the aircraft has to be pushed back until there is a minimum of 1 aircraft distance between the aircraft and the terminal before permission can be given for startup. In case there is another aircraft boarding passengers from the left side or refueling from the right side in the direction of jet blast, permission to start engines must be given while the aircraft is turning to prevent any untoward incident due to the effects of jet blast.
Professor, doesn't the aircraft size also determine engine startup?
You are absolutely right, Professor. For a wide body, permission is given to start up only 1 engine during pushback. If we start any more engines, the power of the engines will put more weight on the aircraft body, which the tow truck will not be able to handle. It will destabilize the aircraft and may result in damage and problems like shear pin cut in the tow bar.
The weather also plays a role in determining engine startup. Remember, the tarmac, especially the yellow paint lines, get slippery during rain or snow, and the power of the engines can make the aircraft slide and result in shear pin snapping and causing damage to aircraft front strut, the tow truck, as well as cause injury to the headset staff.
In case of rain or snow, therefore, permission for engine start must be given only after the pushback operation is over.
What do we do in case there is a fire during engine startup?
Good question, Professor. The headset staff has to immediately inform the captain that there is a smoke out or a flame out, and has to inform the captain of which engine the problem is with. As soon as the captain has been informed of the problem, everyone has to follow captain's instructions only. Well, fortunately, this aircraft has no such problems and has now been pushed back to a position where it can start all its engines and proceed for takeoff.
The tow truck driver now uncouples the tow bar first from the tow truck and then from the aircraft. He then reconnects the tow bar back to the tow truck, and now the tow truck leaves.
The headset staff then takes the bypass pin back from the aircraft. Remember, the aircraft wheel turning may cause injury, so the staff has to ensure that they are standing opposite the front strut wheels. He holds the towing lever with one hand and removes the bypass pin. The headset staff then walks away from the aircraft until he reaches a position where he is at 30 degrees from the nose and turns and makes direct eye contact with the captain. He holds the bypass pin in the hand which is in the direction which the aircraft is to drive to the taxiway and shows the captain that it has been removed. But even now, he has to check that the aircraft's path is all clear, and only once he is satisfied that there is no obstruction does he give the signal for the aircraft to leave by lifting the arm with a bypass pin.
Before moving away from the aircraft at the end of the operation, staff has to ensure that headset, tow bar and shear pin and the bypass pin have been taken back from the aircraft. Remember, the bypass pin restricts mobility of aircraft and leaving it in will cause an accident.
Let us just do a quick recap on precautions to be taken during the pushback operation. Wear luminous vest. Keep your hands empty of any material. Perform operation at walking speed. Do not pass over the tow bar during operation. Always keep distance between aircraft and pushback vehicle during operation. Keep eye contact with wing walkers during operation. Stop operation in case the headset cable comes out. Stop the operation in case of any obstruction. Do not connect the tow bar to aircraft while the aircraft is fueling. Ensure the tow truck engine is running when the tow bar is connected to tow truck vehicle. Headset staff should be to the starboard side during pushback. In case there is a change, this must be first communicated to the captain before pushback. All staff must be careful during the operation.
Professor, isn't there a standard principle governing the engine startup order?
Yes, there is. The startup order of engines depends on where the hydraulic system which supplies the parking brake is located. During engine startup, the engine-driven pump pressurizes the hydraulic system and makes the parking brake more effective. For example, a narrow-bodied aircraft, Airbus A320, the yellow hydraulic system is located below engine number 2. So, the engine startup sequence would be 2, 1.
Professor, wide-body aircraft have 2 hydraulic brake systems each below the engine, don't they? So what would be the engine startup order in that case?
Yes, Professor. A wide-body aircraft has 2 hydraulic brake systems below each engine. For example, in an Airbus A340 aircraft, the engine startup order would be 4, 1, 2, 3. This is to keep the aircraft sturdy while the engine run takes place, and the hydraulic brake system located below each engine helps and supports to keep the aircraft stable during engine run-up. In case of engine startup with APU or GSU, we must make sure that procedure is followed. Firstly, we have to confirm with the captain which engine he will start up. A walk-around check is performed. We have to take captain's permission before the tow bar and bypass pin, if used, are connected. Once the captain gives the OK, the ASU is started. The ASU and GPU are disconnected from the aircraft. Normal pushback operations start after this.
Professor, we can also have pushback operations without a tow bar, right?
Yes, of course, Professor. There are tow barless tow trucks which are used for this operation. In fact, let's take a look at this pushback operation. It is going to take place with a tow barless truck. First, the headset man connects the bypass pin and does a walk-around check. He checks to see that the wing walkers are in place. The captain confirms that the brakes are set. The front wheel chocks are then removed. The tow truck moves forward and attaches itself to the aircraft wheels. The tow truck then lifts the front wheels of the aircraft. The wing walkers then remove the rear wheel chocks. The headset man informs the captain that the aircraft has been lifted and is ready for pushback. The captain releases the brakes. The headset staff confirms this by checking that the front brake lamp has gone off and the pushback begins. Once the aircraft has reached the desired position, the captain starts the other engines and the brakes are clamped on. The aircraft wheel is lowered and released. The headset cable is removed. The bypass pin is taken back and the tow truck and the headset staff move away from the aircraft. Headset staff holds the bypass pin up and stands in position till the aircraft leaves.
What happens, Professor, in case the headset goes out of order?
In case the headset is out of order for some reason, then manual pushback is conducted in accordance with the aircraft type and the airline company. In such a case, the headset staff performs a walk-around check of the aircraft. He then stands on the left of the aircraft in eye contact with the captain of the aircraft, and all signals are hand signals. A word of caution is necessary here, Professor. During manual pushback, the staff must wear protective earplugs or muffs to prevent hearing damage.
Professor, do aircraft always have to be pushed back?
No, aircraft don't always require pushback. For example, if you take a look at that aircraft, it is parked in an open parking slot at 45 degrees to the ramp. The pushback staff has to mandatorily conduct a walk-around check. The pushback staff must go to the rear of the aircraft and check that there is no obstruction for engine start. The pushback staff then goes to the front of the aircraft and signals the engine start either through the headset. The process of OK signaling should finish quickly after the aircraft starts turning and the captain can see the rear of the aircraft. Remember, staff should stand in the safe area to be out of the jet blast zone.
Could you run through a checklist of things we have to remember about the towing operations, Professor?
Yes, of course. Firstly, the walk-around check to see that all doors and holes are properly secure is mandatory. During the pushback operation, the headset staff must walk. In case the operation is long, the headset staff can be inside the tow vehicle, provided there is a wireless headset being used. When the operation is being conducted in temperatures of extreme cold, brakes must be clapped on and the aircraft must stop before turning regardless of the angle. If there is a downward slope, the tow truck must ensure extremely low speeds to prevent the weight of the aircraft from causing a detachment from the tow truck. In case an aircraft is being towed to the hangar or it is being towed between two aircraft, then there should be sufficient wing walkers to secure the wings. The wing walkers must remain in contact with the headset staff via eye contact and walkie-talkies.
A word of caution is advisable here, and headset staff should know that it is dangerous to conduct pushback operations while sitting on the tow truck.
Well, that was an interesting practical lesson on marshalling and headset operations. Let's take a break here and we will return to the classroom for our next module on communication.